Hello. In this video, we're going to look at some chain rule problems that are quite complicated. If you look at some of these chain rule questions here, we have product rules, quotient rules, really some difficult questions. And so what I want you to do is to pause the video, copy down these questions, and try them on your own. Think of it like a problem-solving session. Do your best to come up with answers to these, or at least partial answers if you get stuck. And then in the next section of the video, I'm going to go through the answers to these one at a time. So let's look at this first function here. We have to find the derivative of, well, there's all this stuff inside the square brackets to the power of 4. Then there's a minus 3x plus 4. Now, just to clear it up right at the beginning, this stuff at the end is not too difficult. We're going to have to just put a minus 3, because the derivative of minus 3x is minus 3, and there'll be a 0 for that 4. So at the very end of our final big expression for the derivative, we're going to have a minus 3 outside the brackets. But let's focus on this part here. We're going to find the derivative, and we have to work on that first part, which is bringing down that 4. So we bring down the 4, and we get x plus sine squared x to the power of 3 plus 5, all to the power of 3 times. So now we have to use the chain rule, and we're going to look at each piece of the function. In particular, there's going to be an x plus another term plus another term. Well, we can do each piece of the addition one by one. The derivative of x is simply 1. The next piece, though, requires a chain rule again. So we do 3x plus sine squared x to the power of 2 times. Well, now in here we have 1 plus, because the derivative of x is 1. Sine squared will be 2 sine to the 1, if you want, times cos x. So that finishes off the derivative for this term here. And then we know the derivative of 5, of course, is 0. So we can close off the brackets. But don't forget that we have to now do the derivative of the final terms, the minus 3 and the 4 that we talked about earlier. So we should add our minus 3. Let's look at the next question. So here we have what looks to be two functions being multiplied together. So we'll use our good friend the product rule. F prime x equals negative sine bracket root sine pi x times, well, this also requires a chain rule. We're trying to do the derivative of the first term, and my goodness, we have a lot to do here. If you notice, we have the root of sine pi x, which can be rewritten as sine pi x all to the power of 1/2. So we can write that in terms of a derivative. We know the power rule will bring down that 1/2, and we'll get times 1/2 sine pi x to the power of negative 1/2. Next up, we do the derivative of sine x, which we know is going to be cos x. So we get cos pi x. And we have to write down the derivative of pi x, which is just pi. So we have to multiply by pi. And that is all the derivative of the first term. Multiply by, leave that second term alone, tan e to the 3x plus 1 plus x plus 4 plus. Let's go ahead and do the derivative of the second term. Of course, leave that first term alone. Cos root sine pi x times, and I'm just going to start this on the next line here. It's getting pretty messy, but trying to follow along with the work. This is going to be in another set of brackets. Derivative of tan, secant squared. Leaving the inside alone, e to the 3x plus 1 plus x plus 4 times, well, the derivative of e will just be e, so e to the 3x plus 1 Derivative of 3x plus 1 is 3. Derivative of x is 1. Derivative of 4 is 0. Close off that bracket. Close off this bracket, and you're done. We have finally come up with our derivative. Again, there's a lot to keep in mind as you're working through this, but as long as you do each rule step by step, you should get the answer. Now, for this function here, you can see that the square root is the very first thing you encounter. And so you're going to want to rewrite that square root as all to the power of 1/2. So you can see that the power rule is the very first thing to do. So when we go to do the derivative, f prime x is going to be 1/2. And then everything else gets rewritten. Secant of e to the 5x squared over cotan of e to the x plus x squared plus x to the power of -1/2. That's the very first thing to do. The derivative of the root, the power rule, is applied at the very beginning. Then we multiply and we start doing, well, it looks like we have to start doing the quotient rule. So this is going to get pretty nasty. We're going to have to do low d high less high d low over the denominator squared we go. So let's give it a whirl, see what we can come up with. So if we write low d high, we're going to have cotan e to the x plus x squared plus x. That's our low. D high. Well, the derivative of secant we know is secant tan, so secant e to the 5x squared times tan, well, I'm probably going to have to do that on another line here, times tan of e to the 5x squared times the derivative of e we know is just e, so e to the 5x squared times 10x. So here we have low d high less, well, let's go ahead and do high. So we're going to rewrite that high, secant e to the 5x squared, then d low. Well, the derivative of cotan is negative cosecant squared e to the x plus x. But we've got a chain rule there as well. So multiply by e to the x plus 1, because the derivative of e to the x is e to the x, and the derivative of x is simply 1. Then we have to do the derivative of these other two portions, because these are both in the bottom. Now, because we're adding, we can just go ahead and add each one of these derivatives. No need to do product or chain. So the derivative of x squared is 2x, and the derivative of x is 1. So we can go ahead and add 2x plus 1 and close it off. So that's our low d high less high d low. And then we have to put all over the denominator squared. So we rewrite that denominator again, cotan e to the x plus x plus x squared plus x, and we square it all. So just zooming out here to take a look at our final answer. As long as we've got the 1/2 coming down and rewriting, then we have to multiply by this crazy quotient rule. It would be a little bit nicer if you could try to fit the quotient rule on one line. Having it split up into multiple lines like this does look a little bit messy, but as long as you're able to have proper arrows, and if you have some nice brackets, you'll get full marks on the question. Let's take a look at the final question. This one here is a doozy. Again, there's a power and then some chain rule going on, and inside it looks like we might have a quotient rule as well. So let's see what we get. We're going to do that power first. So f prime x is going to equal 1/2 cosecant e to the x minus x plus 2 e to the x plus Now I'm going to write this as 1/2 x to the minus 1, just to set it up for when we go to do a derivative later. We never like to leave our x in the bottom. We always like to write it as a power. This will be negative 1/2. Let's go ahead and move the screen on over and do the derivative of cosecant, which we know is negative cosecant cotan. All the rest is going to be rewritten though. So we're going to have bracket negative cosecant e to the x minus x plus 2 over e to the x plus 1/2 x to the minus 1 plus 1 cotan of the same thing. All right, close off that bracket. Now we do the derivative of the inside. Again, just to take a step back for a second, the way I think about this is I do the derivative of the 1/2, then I cover up the 1/2 and pretend it doesn't exist. I look at the cosecant and do the derivative of cosecant. Once I've done that, I cover up the cosecant and pretend it doesn't exist. And I do the derivative of that inside, which looks like a quotient rule. So let's keep going here. Times. So we're going to do low d high. Low is going to be e to the x plus 1/2 x to the minus 1 plus 1. D high is going to be e to the x minus 1 less, let's just keep moving this screen on over, high e to the x minus x plus 2, d low. So we have e to the x minus 1/2 x to the minus 2. All over, so this is all over this whole thing, the denominator squared. E to the x plus 1/2 x to the minus 1 plus 1 squared. So hopefully you were able to get similar results. Maybe you got stuck here or there, but hopefully you were able to get most of that question. And if you weren't, go ahead and try it again yourself. You can always rewind the video if you get stuck at any point. And as always, if you have any questions, please feel free to let me know. So for homework, you can take a look at the chain rule worksheet. Hopefully you enjoyed this video, and as always, thanks for watching.